Now we're going to look at amortization. A loan is amortized if both the principal and interest are paid by a sequence of equal periodic payments. Normally, you will know how much the loan is for, and you have to find the payment necessary to pay off, amortize, the loan, which is the principal plus the interest. Now, my amortization payments, if you'll notice this formula, it should look familiar because it's the present value of an annuity formula. When you go borrow something, you know how much you have to borrow, but you don't know how much you have to pay in order to pay off that loan. So if you'll notice, here's my P equals, here's my payments, and I divided both sides by my bracket. Okay? So it's the same formula, except we're looking for what our payments would be. Alright, so let's see. Some examples. A recreational vehicle costs $80,000. You pay 10% down and amortize the rest with equal monthly payments over a 7-year period. If you pay 9.25% compounded monthly, what is your monthly payment? How much interest will you pay? Now, the first thing we have to do is see how much that money that we're going to have to actually amortize, because there is a down payment of 10%. So, if you remember, if you take the amount, and down payment means you're paying that much, and we subtract from, okay, what the whatever the item is, be it a vehicle or house or whatever. If you have a down payment, you subtract, because then this would be the actual money you would borrow. The more you can down pay, then the less money you have to borrow. So the next thing we're going to have to do, it says we're going to have to find our payment. So here's how we go find our payment. That's the formula. So the P is representing how much money we have to borrow today in order to get this vehicle. So our R, N's, and T's are the exact same thing. So see if you agree with this. Now, VI calculator, same thing. I've got to find this number in my bracket. So let's go store that 0.0925. And let's go do our numerator. Remember, we got to do our numerator first. So 1 minus parentheses 1 plus x raised to, now that would be negative 84, but if you don't want to have to worry about that, remember to put it in parentheses. Do not forget that negative. So hit enter. So that's the number in my numerator. I'm still in my bracket, so I need to divide by what I stored by earlier. Okay, so that's the number here. I need to divide 72,000 by that number. So 72,000 divide by second answer. Remember, I said you can either type it in or do the second answer thing. So we're going to have to pay $1,167.57 to amortize this loan. Now, the next thing, how much interest will you pay? Well, you've got to remember, we made some payments, a series of payments. So, we have got that much that we're going to pay for that many months, that many years. Then we subtract what we borrowed. Okay, so 1167.57 times 12 times 7 minus the amount borrowed. Maybe I'd get a cheaper recreational vehicle. But anyway, when you do this, remember, this is the money. If you had not gotten it, the bank would have, possibly invested it for even more. But you're paying for the use of that money. Let's see, a family is thinking about buying a new house costing $120,000. The family must pay 20% down, and the rest is to be amortized over 30 years in equal monthly payments. If money costs 7.5% compounded monthly, what will the monthly payment be, and how much total interest will be paid over 30 years? Alright, so let's go first find out what our actual loan's going to be that we're going to have to amortize. So I have $120,000 minus 20% down, which is 20% of that amount. So 120,000 times 0.20. So this is what we're going to be borrowing. Okay? So first thing we got to do is go find our monthly payment. So I'm going to be using that formula. So put in, let me see, 96,000 is what we're getting today to give to the owners, and put in the appropriate values and see if you come up with this. I'm getting very irritated with that thing. Calculator, you go try it. There's the numerator of my bracket. Divide by my stored value. There's my number that's in my denominator. So 96,000 divide by second answer. So we're going to have to pay $671.25 every month for 30 years. So, total interest paid. Let's go find out how much we're going to be paying in all. So if you do that, times 12, because we have to pay every month for 30 years, and subtract the original amount that we borrowed, and you're going to have to pay back that much in interest, which is a heck of a lot more than what you borrowed. But that's how this thing works. Especially the longer you have the loan, then the more you have to pay. So if you could have a shorter amount of term, say 20 years, you would be paying a whole lot less. I think there's some problems in the homework that you see the difference there. I've got a few more problems I want to look at. Unpaid balance of an amortized loan. The unpaid balance of an amortized loan is equal to the present value of the remaining unpaid payments. Since the payment's already known and the amount of time left is known, then we can still use the present value of an annuity formula. So solving for P will tell us what our unpaid balance is. So I've got another example here. A family has a $210,000 20-year mortgage at 6.75% compounded monthly. Find the monthly payment. Also find the unpaid balance after 5 years, 10 years, and 15 years. So the first thing we're going to do is just go find the monthly payment, which means I've got to go find this, use this formula. So why don't you stop me and you go and put in the values and see if you come up with what I do. And you should come up with this much monthly payment for 20 years. So now, the balance after 5 years means that there's still 15 years on the loan. So when we want to find what the unpaid balance is, well, I'm going to use my present value formula because I know this, and the time, I still have 15 years on the loan. So let me put in the values in the appropriate place. Notice this information here is the very exact same thing, except you indicate how much time's left on the loan. And if you work that out, you should come up with that. So after 5 years, this is how much they have paid on the original amount that they borrowed. Depressing. Let's see about the balance after 10 years. And the only thing that changes, all of this is going to be the same except the time left on the loan. So I'm going to have 10 here. And you got to go through the process all over again, and you should come up with that. So paying 10 years, you've paid that much. Close to what? A tad over or a tad under 80,000 or less. Well, 70. Yeah, just 70,000. 10 years will be. It's just depressing, and I'm having to go through this. I used this formula right here just to make sure that the bank got it right. Well, that's me though. I'm a math person. Let's see what happens, the balance after 15 years. You still have 5 years on the loan. So the only thing that's going to change is the amount of time still on the loan. Get that thing down here. And if you work that out, then 5 years still on the loan, they still owe $81,121.91. But now this was not part of the question, but I just wanted to see it. Now, let me see, monthly payment. How much interest will this family pay in all? So the monthly payment was $1,596, right? Yeah. Okay. So let me move this over. And I can't stress enough that you've got to remember you have to multiply this by 12 because you do it every month for 20 years. And then you're going to take off the amount borrowed and how much interest they're going to pay in all. Almost not as close to, but about as much as they borrowed. It's sickening, but that's what happens. If you could pay just a little bit more each month, $25 or even $50, it would shorten the amount of interest that you'd have to pay because that $25 or $50 comes directly off of the principal. Okay? So that's it for this particular section. So you got some problems to do, and hopefully you won't get too sad looking at some of those problems. Thank you.